Welcome back to Algebra 2, Priority Standard 6. Today we are going to finish Learning Target 6.2.1 on simplifying rational expressions. So in our last two videos we had topics involving multiplication and division of rational expressions, and today we're going to focus on the last part of this skill, which is adding and subtracting. So let's start off with some fractions that just involve numbers here. So no rational expressions yet, but how do we add or subtract fractions? Step one is going to be to multiply to get a common denominator. So we're going to multiply to find a common denominator, that is sometimes abbreviated LCD for least common denominator. And then step two is going to be to add or subtract just the numerators. So once you have the common denominator, that's going to be the denominator of your final answer. We are just adding or subtracting the numerators, the tops of the fractions. So in an example like this first one, 4/3 plus 7/3, those have the same denominator. Thirds are the same size as each other, so we can just add straight across. 4 plus 7 becomes 11, and that denominator is still a 3. Same thing here with 5/6 minus 1/6. 6 and 6, we already have common denominators, so we can just subtract the numerators. 5 minus 1 is 4. Denominator stays as 6. And then there will be times like this one where you can simplify that. 4/6 is the same as 2/3. Now the problem down here, like this one in the corner, we've got 3/8 plus 1/4. A fourth is a bigger fraction than an eighth is, so we can't just combine those. They're not all the same size of pieces. So what we want to do is multiply by something so that these numbers are the same. And that's pretty easy to do. If we multiply 4 by 2, it will become 8. So whatever you do to the bottom of the fraction, you also have to do to the top. So basically, I'm multiplying by a creative form of 1. Multiplying by 1 doesn't change the number at all. Multiplying by 2 over 2 doesn't change the number either. So this stays as 3/8. But now instead of having 1/4, I have 2 over 8. And now that we have common denominators, I can add straight across. 3 plus 2 is 5, 5/8. And same idea for this one over here. It's very common to need to multiply each fraction by the opposite denominator. So 4 and 3 don't really have anything in common, but they are both factors of 12. So I want to get my denominator here to be equal to 12. That one will be common to both. So I'm going to multiply this first fraction by 3 over 3 and the second fraction by 4 over 4. And if I do that, then I've got 3 times 3, which is 9, over 3 times 4, which is 12, minus 1 times 4, which is 4, over 3 times 4, which is 12. And see, now we have the same denominator on both pieces of the fraction. So now I can just subtract. 9 minus 4 is equal to 5. 5 over 12. So that's the basic idea. When you are adding or subtracting fractions, you want to first find a common denominator and then add or subtract straight across the numerators. And the same set of steps is going to hold true when we have variables. So now instead of just having fractions, we have rational expressions. I see x's in the denominator. First one though, same exact thing applies. X minus 5 and x minus 5. That's the same denominator both times. So all I need to do is subtract the numerators. 8 minus 1 is 7. And the denominator x minus 5 stays the same. Same thing here with the second one. 2x plus 4, 2x plus 4. The denominators are already exactly in common, so all I need to do is add the numerators. 11 plus 6 is 17 over that common denominator of 2x plus 4. Now on this third problem, the denominators are not exactly the same. This is x minus 3 and this is 2x minus 6. So I need to multiply one of these by something to make them the same. And that's pretty easy to do. I know that x minus 3 is half of 2x minus 6. So if I double it, if I multiply this first fraction by 2 over 2, then 2 times 1 is 2 in the numerator, and then I will have 2x minus 6 in the denominator, and that will be added to my second fraction, 5 over 2x minus 6. And now that I have the same denominator on both sides, I can just add the two together. 2 plus 5 leaves me with 7. 7 over my common denominator, 2x minus 6. And this one here, I see a denominator of 5 and a denominator of 5x. So to make those the same, this first one needs an x. I've already got the 5, but I'm going to multiply by x over x. X times 4 is 4x over x times 5, or 5x, minus 1 over 5x. Now, when I go to subtract, notice that these are not like terms. So 4x and 1, those don't combine. So we will just have to keep it as separate terms, 4x minus 1, but we can write it as one big fraction all over this common denominator of 5x. So even if your like terms don't combine, you can write it as one big fraction instead of two separate fractions. So these are some simple examples of today's learning target where we are adding or subtracting rational expressions. It can get a little bit more complicated when there are bigger expressions involved. So step 1 is going to be to look for anything that will factor, especially in the denominator. Then step 2 will be to find the LCD. Remember, that stands for least common denominator. We need to make all the denominators exactly the same. And then step 3, we will finally be able to add everything together. So looking at this first example, x, there's nothing to factor there. In the denominator, x plus 3, nothing to factor there. Plus 3x, that's all good to go. But now I see this x squared plus 8x plus 15. Whenever you see a quadratic, probably should think about factoring that. So ask yourself, what multiplies to 15 and adds to 8? And that's going to be 5 and 3. X plus 5 times x plus 3. So now we need to look at these denominators and see what do we need to do to make it all come out to be the same denominator. So I notice that both of these terms already have an x plus 3 in the denominator. That part is in common, but the second term has an x plus 5 that the first term is missing. So to make them exactly the same, I need to add in, or rather multiply in, an x plus 5 on this first term. See, now we've got x plus 5 times x plus 3. X plus 5 times x plus 3. It's the same denominator on both pieces. So here we have a little bit of tidying up to do as we add across. Right here on this multiplication, I need to distribute. X times x becomes x squared. And x times 5 becomes 5x. So I've got x squared plus 5x rather, over x plus 5 times x plus 3, plus 3x over x plus 5 times x plus 3. So I would say finish out your multiplication first, do any distributing that you need to, And now we can do step 3, which is to add everything up. So I am adding here x squared plus 5x plus 3x. So there you just want to combine your like terms. X squared doesn't combine with anything, plus 5x times 3, or 5x plus 3x. Those two will combine to give me 8x. So we've got x squared plus 8x all over my denominator, x plus 5 times x plus 3. And that would be your final answer. X squared plus 8x all over x plus 5 times x plus 3. If you wanted to FOIL it back out and write x squared plus 8x over x squared plus 8x plus 15, you could do that as well. Either of those would be considered correct. Let's do another example. Here we have 5x over x squared minus 4x minus 12 plus 7 over x minus 6. So step 1 is to factor anything that we can. So 5x is not going to factor, but x squared minus 4x minus 12, that quadratic, definitely is. So we're looking for numbers that multiply to negative 12 and add to negative 4. That's going to be negative 6 and positive 2. So x minus 6 and x plus 2. And then this second fraction doesn't have anything to simplify. 7 is good. X minus 6 is good. Step 2 is going to be multiplying to find a common denominator. So we need the bottoms of both fractions to be exactly the same. Right now they do have the x minus 6 in common, but the second fraction is missing the x plus 2. So I'm going to multiply in an x plus 2. And whatever you multiply to the bottom, you also have to multiply to the top. And we'll tidy this up a little bit. The first term has not changed. It is still 5x over x minus 6 times x plus 2. The second term now, we have some multiplication to do. 7 times the quantity, x plus 2. We need to distribute that. So that will be 7x plus 7 times 2, which is 14. And now this term has a denominator with 2 parts to it, x minus 6 and x plus 2. So we've got our common denominator. Both of these fractions have exactly the same terms underneath. So now we can just add the numerators. So I've got here 5x plus 7x plus 14. So 5x and 7x, those are like terms. 5 plus 7 will give me 12x. So we've got 12x plus 14 all over this common denominator of x minus 6 times x plus 2. Again, you could also write that as 12x plus 14 over x squared minus 4x minus 12. Either of those would be considered correct as the sum of these two fractional expressions. Now, when we are subtracting expressions, it is the same exact set of steps where you're factoring, you are finding the common denominator, and then you are adding like terms. The difference is that we need to remember to distribute the negative. So that's the very first thing you want to do. So if you see that this is being subtracted, you are going to distribute that negative sign to every part of the numerator, which in this problem is just the 7. And it only goes to the numerator. So this x squared plus 6x plus 8, that all can stay positive. We are just going to change this into an addition problem and make the numerator negative 7 instead of positive 7. You can think of it, subtracting 7 is the same as adding negative 7. So distribute the negative first, and then from there it is the exact same as your addition problems. So 9x over x plus 4, nothing to factor there. This is being added to negative 7 over, and here's where we need to factor, what multiplies to 8 and adds to 6. That's going to be 4 and 2. So x plus 2 times x plus 4. So step 1 is to factor. Step 2 is to find common denominators. So here we have the x plus 4 in common. The second term has an x plus 2 that the first one is missing. So we need an extra x plus 2 term right there. And whatever I do to the bottom of the fraction, I also have to do to the top of the fraction. So we've got x plus 2 multiplied by 9x over x plus 2 times x plus 4. So when you are multiplying, you need to distribute. So we're going to multiply right here. 9x times x will give me 9x squared, and 9x times 2 will give me 18x. And this is over my now 2-term denominator, x plus 2 times x plus 4. And we are adding to this my second term, which hasn't changed at all, negative 7 over x plus 2 times x plus 4. And now that we have common denominators, both of these are over the exact same set of factors, we can add across the numerator. And now here I don't have any like terms. 9x squared plus 18x plus negative 7. Those, none of them combine. So it's just going to stay as 9x squared plus 18x plus negative 7 is the same as minus 7 all over x plus 2 times x plus 4. In other words, 9x squared plus 18x minus 7 over x squared plus 6x plus 8. Now you might be saying, Mrs. Hunt, why did you make such a big deal about distributing the negative? It's potato, potato. We're subtracting 7, we're adding negative 7. We end up with a minus 7 here at the end either way. And hopefully that will become clear on this next problem, because when you have more than one term, here we have minus 5x plus 8. A lot of people will remember to subtract the 5x, but they'll forget that the 8 here in the numerator is also being subtracted. So distributing the negative right away helps us make sure that we are subtracting all the pieces, especially if there's more than one. So I'm going to change this into an addition problem. I'm going to make the 5x negative, and I'm going to remind myself that the 8 is also negative. The 8 is also being subtracted. Once I've done that, we will factor and find some like terms. So we've got 2 over x minus 5, and this is being added to negative 5x minus 8 over, and now here's where the factoring comes in, what multiplies to negative 10 and adds to negative 3. That is going to be a positive 2 and a negative 5. So x plus 2 and x minus 5. So common denominators, we already have the x minus 5 on both, but this first term is missing the x plus 2. So to make the denominators exactly the same, I need to multiply in an x plus 2 here on the left, and that's going to be multiplying really by x plus 2 over x plus 2. When you are multiplying with parentheses like this, we need to distribute. So 2 times x is 2x. 2 times 2 is 4. So we've got 2x plus 4 over x plus 2 times x minus 5. And we are adding to that my second fraction, which hasn't changed at all, negative 5x minus 8 all over x plus 2 times x minus 5. And now that we have common denominators, we can simply add across the tops, combining any like terms that we can. Here I have a positive 2x and a negative 5x. So those are like terms. 2 minus 5 leaves me with negative 3x. And then I've got here a 4 and a negative 8. Those give me negative 4. 4 minus 8 is negative 4, all over x plus 2 times x minus 5. Or in other words, negative 3x minus 4 over x squared minus 3x minus 10. So you can see on this problem why it is important to distribute the negative. We need to remember all the way along here that this 8 is being subtracted. A lot of people will forget to distribute the negative, and they would give me an answer of negative 3x squared plus 12. They would add the 4 and the 8 when really it's supposed to be subtracted. So remember, on your subtraction problems, distribute the negative, and then for all of these, you will be factoring, finding common denominators, and then adding across to combine your like terms. So that is it for Learning Target 6.2.1. We have now covered all of these different skills of simplifying rational expressions, whether they involve multiplication, division, or addition and subtraction.